This lesson deals with supplemental problem 210. You can find this problem in the course ebook in the Chapter 2 Supplemental Problems on page 11. Let's find the equivalent resistance between terminals A and B. To be in series, you share the same current. 32 is in series with 40. Add those two together, you get 72. To be in parallel, you share the same two nodes. Now in this example, I'm just showing a single node as a connection point. All of this is a node, all of this is a node, all of this is a node, and likewise this was a node. And lastly, so is this one. The 6 and the 12 are between the same two nodes. So here's a node, and here's a node. So they're going to be in parallel, which would be the product over the sum. That would be 72 divided by 18, which turned out to be 4. And these two are also in parallel. They're between the same two nodes. Product over the sum would be 6 times 30, which is 180, divided by 30 plus 6, which is 36. And that turns out to be equal to 5. Now in this example, in the previous one, all the answers were turning out to be whole numbers. This was designed to be that way. But on tests, and of course in building real circuits, it won't turn out to be nice whole numbers, but we'll have many places. So let's reduce our circuit to 72 ohms. We have 4 ohms and 5 ohms. Now the 4 ohms and 5 ohms are in series. They share the same current, so that would be 9 ohms. And that's in parallel with the 72. So here's my 9, here's my 72, and they're in parallel. So that'd be the product over the sum. So 9 times 72 over 9 plus 72 turns out to be equal to 8. That 8's in series with 2, so that makes that 10. And then all that's in parallel with 15. Combine these two together, get 10. So it's a single resistor. And that's going to be in parallel with 15. So product over the sum, 15 times 10 over 15 plus 10, or 25. And that turns out to be equal to 6. That's in series with 4, and so we get 10 ohms for our equivalent. And this is supplemental problem 210.